realize it, but to be watching this lecture, to have turned on your computer, to have eaten a meal today, to shower, to talk to friends, all of this is brought to you by a chaotic but highly planned network of physical infrastructure. By the textbook, infrastructure is the fundamental facilities and systems serving a country, city, or other area, including the services and facilities necessary for its economy to function. In the real world, it's so much more than that. What brought us to this point, to where cities have become such complex systems within systems? To better understand the evolution of infrastructure, and thus the evolution of the city, we need to go back in time. A bit further. Farther. Keep going. Too far. There we go. The year 7100 BCE. The place, Çatalhöyük, Turkey. Discovered in 1958. This is the earliest known example of a rather sophisticated urban center. A place that cradled early civilization, where civilization and the concept of dense, cooperative urban agglomerations were still a very new concept. An even newer concept, and what makes Çatalhöyük an interesting case study, is the planned nature of the city. Living in such close quarters meant that even this primitive city needed complex infrastructure. There were roads and walkways, pathways to handle waste, ways to bring in water, food, vendors, all the ingredients that make city life possible. Even in our earliest known cities, infrastructure made the whole thing work. Çatalhöyük isn't alone in its historic development of infrastructure. The ancient city of Ur, founded in 3800 BCE, located in modern-day Iraq, had an intricate sewer system that removed wastewater out of the city and into the Euphrates River. And of course, you've heard of the Romans. They created the first recirculated water supply systems. The Romans were skilled engineers and a civilized and democratic society. The vast public works were popular, planned, and quite comprehensive. Human waste was then, and still is, one of civilization's most difficult and expensive problems to deal with. For thousands of years, waste was dealt with by digging cesspits. While these pits hide the waste and made things moderately better by reducing the spread of disease, they created new problems for those that stumbled upon the pits and from a dangerous accumulation of gas. The Romans found infrastructure-based solutions to this problem with the creation of public toilets and a sophisticated underground sewage system. Roman engineering also gave the world its first constructed road systems. These roads included intercity country roads and in-town street networks. Romans were also mobile, and to facilitate that outward movement, they built complex ports. Some Roman ships carried up to 1,000 tons of goods. For reference, a single 250-ton load took 6 to 8 days, and cranes had to be used in the process. Over time, the Romans built hundreds of these ports in the Mediterranean. Civilization began to appear as a result of humans developing surpluses of food. Agriculture depended on irrigation, which came in the form of canals. In turn, the canals helped to transport food that could be traded for other goods, allowing entire cities to concentrate on things they were good at doing and import what they needed. More towns developed where trade took place along trading routes and roads. In the process, people traded goods, but they also exchanged ideas about philosophy, medicine, mathematics, technology, astronomy, religion, and engineering. With new time away from labor, minds were free to set about creating civil and educational institutions, and over time, thanks in large part to infrastructure, our modern society arose. These early civilizations planted the seeds of the modern city with many of the same types of physical infrastructure we still build to this day. And as our own modern cities grow, we continue to face the challenge of expanding our infrastructure to meet the needs of our society.
Auckland has seen tremendous growth in recent years. Record transport investment has been unable to keep up, and 1.5 million Aucklanders feel the effects of a strained system every day. Public transport is struggling to cope. Drivers face ever-increasing congestion on our crowded roads, reducing our international competitiveness and Auckland's reputation as a livable city. A recent NZIER report shows that this situation is costing the economy up to $2 billion per annum in lost productivity, with predictions that the population will increase to 2 million people within 15 years. Things are going to get much worse. Part of the problem is that this growth is happening everywhere at once, with intensification in the suburbs, often where it's not welcome, and sprawl to the north, west, and south of the city. This strategy puts additional stress on the existing public transport and road network, which is already under pressure. To design and build adequate infrastructure to meet the growth demands of all these areas at once would be very ambitious, very expensive, and hugely disruptive. So how do we solve the problem? More of the same may not be the answer. But what if we were to think differently? Why not select available development areas adjacent to existing public transport corridors and close to natural assets such as power, water, and aggregate supplies for construction, which all come from the same direction, the south? This approach would make it cheaper and easier to build and service not only our immediate requirements for 40,000 households, but for a forward-thinking, innovation city of 400,000 or 500,000 households, a satellite city of the future, a city with medium and high density living, affordable homes, integrated social housing beside rail and busway corridors so people can walk to the station or walk to work. We could design a city that delivers all of our aspirations of the future. Parklands, waterways, schools and tertiary facilities, a hospital, theatres, commercial and industrial hubs connected by walkways, cycleways, and efficient public transport services. The city would be the ultimate in sustainability, with the latest in technology, solar, recycled energy and water, driverless cars, autonomous buses and light rail. It would be connected by express train services to employment hubs at Manukau, Mount Wellington, Penrose, Newmarket and the CBD, strategic road access routes to the southwestern motorway from Karaka to Weymouth, connecting Drury to East Tamaki, and a connection to the airport by light rail. It would be built on a scale attractive to domestic and international development companies, achieving economies of scale in innovative design and construction. Let's not retrofit our city. Let's evolve into something new, something better and more exciting.